And so I've gotten to work with Jeff over the last year in my role at C Prime, and I really enjoy my conversations with Jeff. He's a really good communicator, always manages to throw in a good dash of humor to keep things light. And I always leave those conversations wanting to be a little bit more like Jeff. Now I asked Jeff, any kind of points you want to hit in my intro? And he just said to make sure that I let everyone know how young, rich, charming, and handsome he is. Which, I don't know. I feel like you can just get that on your own, but anyway.
You have two young, rich, handsome, and charming men right next to each other here. Emphasis on young and handsome.
Yeah, hard to look at sometimes. But so anyway, with that, I'll leave it to Jeff to fill in the rest of the details. And yeah, take
Thanks,
it away.
Dave. So when I left my house to come here today, there was a fresh coat of ice on my sidewalk. So I'm very pleased that the weather has lived up to the name of this conference. It is in fact code freeze. If there are any of you who are not from Minnesota, welcome. This is it. It's a little weird to be here. I can't remember the last time I gave an in-person talk. I'm someone who has a really hard time with virtual talks. You don't get any feedback, you're staring at your computer screen. I also find it really hard to give a talk without walking around. When I rehearse my talks, I walk around in my office. So it's great to actually be on a stage where I can walk around again and see a whole bunch of people, but it is a little bit strange. I also need to offer a little bit of an apology before we start. You may have noticed that the air quality in the Twin Cities has been really awful this week. Hi, Charlie. And for those of us who suffer from migraines, we've been living in hell for the last few days. So I'm a little fuzzy today. Hopefully my brain won't completely freeze up in the middle of my talk, but if it does, I appreciate your patience. On that note, I spent the first 15 years of my career, mainly in the Bay Area, building interesting software systems, everything from compilers to distributed operating systems to content management systems. And then I moved to Minnesota, and I went to work for a managed hosting data center company. And I got introduced to the world of IT operations. And of course, I approached it from the perspective of a software person. One of the first questions I asked after I got there was, how do you version control your router configs? And the network engineers all laughed at me. That was the strangest question they'd ever heard in their lives. Now, interestingly, not long after, we bought a very early product that was specifically designed to version control Cisco router and switch configs. We are also one of BladeLogic's very first data center automation customers. And my actual job in the company was to bridge the gap between our internal infrastructure team and our clients' application delivery teams. So I think I really can say that I was doing DevOps long before there was DevOps. And so after that, I have spent my time working across the entire development, QA, and operations spectrum. I had the temerity to write a book at one point, which I'm very proud to say was part of the inspiration behind the ideas in the Team Topologies book. For a number of years, I ran my own small Agile and DevOps consulting company, and what I've discovered in recent years is that the problems that I've been asked to solve have become too big for one-person shop. So I decided to join C Prime. We are an end-to-end Agile consulting organization. We provide process, product, and technical agility consulting. And my role there is Director of Technical Agility. I lead our technical coaching practice. And it's really focused on filling in kind of the missing piece of the agility equation, which is a lot of what I want to talk about today. Now, if you've heard me speak in the past, I have a tendency to give talks that can be just a little bit out there. This is not one of those. This is a much more down-to-earth talk. It's a little bit of a crabby old man talk. It seems that as I get older, my talks seem to get a little crabbier all the time. And to be honest, it's a little bit of a DevOps 101 talk. And there are a few reasons for that. The first is that I think the DevOps community, and we're kind of admitting that to ourselves now, did the world a bit of a disservice because we said, well, we're not going to tell you how to do DevOps, but we will tell you very snarkily when we think you're doing it wrong. And so we kind of left people to figure it out on their own, and to some degree they wandered off into the weeds, and we blamed them for wandering off into the weeds. And it's reached the point now that when we have clients come to us and say, we need help with DevOps, the first question we ask is, well, what does that word mean to you? And all too often these days, what DevOps means to people is CI/CD tooling. And so part of what I wanted to do today is kind of sort of bring the conversation back, hopefully in a more pragmatic and potentially more humble way than we did it the first time around. The second reason is that what I've discovered as a consultant is that, first of all, we work with organizations that we assume are really, really mature from an agile DevOps engineering perspective, and they're not. They're way far behind where we expected they would be. And we go in sort of thinking, well, why do you need our help? And then we go, oh, you need a lot of our help. We also work with organizations that are really mature in some ways and really immature in others. And interestingly, it often isn't because they just haven't finished doing what they know they have to do. It's because they've subsetted the problem into the parts they like and the parts they think are icky and uninteresting, and they kind of ignore those other parts. And so all too often we sort of see kind of very dev-centric modernization transformations or ops-centric modernization transformations. And the last reason is that I believe that in a certain way, Agile and DevOps have wandered off a little bit and lost touch with their roots and their history and where they came from and what they were really intended to accomplish in the first place. And so what I want to use resilience as a way to kind of rethink about a lot of familiar practices and kind of bring us back to having a sense of, well, why are we doing this? How do we explain to our stakeholders what the actual underlying point is and how we can know if we're really doing all the things we need to do successfully? Now, one of the orthodoxies of Agile is that waterfall is bad. If you're doing waterfall, you're doing it wrong. Well, waterfall is not bad. Waterfall is very intelligent. It's simply the idea that you have to do things in the proper order. You can't write code until you know what the code is supposed to do. And you can't know what the code is supposed to do until you know what the user need is that's driving that code in the first place. At the very sort of heart of computing is the idea of an algorithm or a recipe. And things happen in sequence. Instructions are executed one after the other. Yes, you can have branches and loops, but there's still an order of operations. I am a huge fan of the Great British Baking Show, which, among other things, is about how well you can follow a recipe. And you'll see a contestant go, oh crap, I forgot to put the eggs into the meringue. I have to start over. You can't just throw the eggs in the middle of the process. It has to go in before the sugar, or however it is you make a meringue. And they'll throw their meringue away and they'll start over. So waterfall is actually a very thoughtful thing that we shouldn't just dismiss out of hand. The problem with it is that it can't handle unforeseen circumstances. Let's say you want to drive from White Bear Lake to the Mall of America. And you go on Google Maps and you map it out, and it gives you a set of instructions in order. And the instruction to go west on 494 for 5 miles doesn't mean anything unless you've gone south on 35E for 10 miles first. But now let's assume you do something really radical and unheard of. You actually print out the directions and you take them in the car with you. Those directions don't help you anymore if there's an exit closed or an accident. The thing that's great about Google Maps on your phone or in your car is that it can give you a new plan as you're executing the old one in response to changing circumstances. And in order to do this, it relies on this very fundamental concept called feedback, which was developed at the dawn of computing and is really part of what computing and computers were designed to do in the first place. And it really got its start during World War II, when a mathematician from MIT named Norbert Wiener was asked by the Navy to try and design a self-targeting turret gun for battleships. The problem was that the human operators couldn't point them quickly or accurately enough to shoot down enemy airplanes that were flying over dropping bombs. And Wiener had a couple of really important insights. The first was that you could make predictions about your enemy's flight path. A plane can't just leap randomly from one point in the sky to another instantaneously. There are laws of physics, there are evasive patterns that pilots use, and you can program that into your targeting system. The second and more important insight he had was that your prediction might not be entirely accurate. The plane might have more or less fuel than you expected, the pilot might be more or less experienced than you expected, and even the act of moving a big heavy turret gun was full of error. And simple things like how hot it was outside, how humid it was, how old the grease and the ball bearings were, could mean that when you tried to point the gun, it might go a little too far or not quite far enough. So Wiener figured out that he needed to build a mechanism into the automation process that he called feedback, where you would take information about the gap between what you expected would happen, where you expected the plane would go, where you expected the gun would go, and what actually happened, and you would feed that back into your prediction mechanism. Now, after the war, Wiener got involved in a completely different kind of research project. He started working with some other MIT researchers who were physiologists, and they were studying something called proprioception, which is a very fancy word for body sense. It's how you move your hand when you pick up a glass or how you walk. And what happens is that your brain sends a signal to your hand telling it what to do, and your hand then sends a signal back to your brain telling it what happened. So for example, if you've ever tried to pick up a glass really, really slowly, your hand starts to wobble, but you can still pick up the glass. That's proprioception, and that's feedback, just like the gun. So Wiener took these two very, very different things, and he came up with a very general principle, which he called cybernetics. It comes from the same word as Kubernetes. It means steersman or good steering. And it's the idea of circular causality and adaptive planning. So if you think about picking up the glass, is your brain telling your hand what to do, or is your hand telling your brain what to do? And the answer is yes. And this idea of steering is really important. When you're steering a car, you have to watch out for extremes. You can't just lock your arms and do this kind of thing. On the other hand, if you kind of steer too wildly, you'll end up spinning out and losing control. So there's a fine line of continually making very gradual adjustments and not assuming that you are just telling the car what to do, but you are also listening to the car telling you what's happening. So why do we need cybernetics? Why do we need circular causality? Well, we live in an economy and we live in a world that is characterized by accelerating rates of change. We could talk for a long time about the pandemic and how it ticks all of these boxes. We never know where the change is going to come from or where it's going to go next. We never know exactly what all of the follow-on cascading changes are going to be. And we can never fully say, well, this is a good change or a bad change. We want more of this change or less of this change. So we really live in a world where we have less and less control and less foresight into what's liable to happen. But even aside from that, in IT, we deal with systems that are very complex. They're very intertwined. We can't completely pull them apart from each other. And even sort of straightforward things. I mean, I've worked on things like network device software patching and OS patching. And it touches everything. It touches the network, it touches the OS, it touches the database, it touches the application. I've seen situations where organizations, they just needed to upgrade the software in their firewall and they had to have 100 teams participating in the testing process to do that. The thing about complex systems is they have a certain unpredictability to them, that we find causality in hindsight. One of the characteristics of complex systems is the so-called butterfly effect. The idea that whether or not a butterfly flaps its wings on one side of the world can affect whether there's a hurricane on the other side of the world. And really all that's saying is that very, very small differences in initial conditions can lead to wildly divergent outcomes, which makes it really hard to model and really hard to predict and really hard to use waterfall, where you say, this is where we want to go and this is the best way to go there. Let's execute on that plan. The other thing about complex systems is they fail unavoidably and unpredictably. There's a fascinating story from Google. A few years ago, they had a major Gmail outage. And it was traced to an engineer misconfiguring a production system. Sound familiar? You might say, well, you should have some automation. They should have had automation to prevent that. They did have automation that was designed specifically to prevent that misconfiguration, but it was offline due to a completely unrelated problem. And so one of the things here, and this really plays into this whole idea of steering, is that when we attempt to control things too tightly, to prevent failure too robustly, systems flip from being sloppy but resilient into being brittle. So we need to navigate that. So we have this idea of resilience, which is the topic of today. And I really like this definition of resilience, which is simply the ability to recover from or easily adjust to misfortune or change. The ability to respond to change. And so the thing is, when we look at things like Agile, they are inherently cybernetic processes. So if you read the Agile Manifesto, the front page are these sort of mysterious value statements. We value working code over documentation. The first time I read that, I thought it was nuts. And it took me a while to go, oh, okay, I kind of get it. But the manifesto didn't give me a lot of help in understanding it. But if you flip over to the back page, there's this set of these 12 principles that are really wonderful and really helpful. And one of them is the idea of harnessing change for competitive advantage. Making the ability to respond to change actually a good thing, right? Normally change, it creates chaos, right? We want change control. Now we're saying, let's harness it. When we talk about harnessing change, we're talking about making it work for us instead of letting it control us. And there's some things that we need to do in order to harness it and not just constantly be updating PHP files in production like cowboys. If you look at DevOps, I bet we could get a different definition of DevOps from virtually everybody in this room. But one of the really good ones, I think, comes from Gene Kim, and the 3 ways of DevOps. The first way is maximizing end-to-end flow, which is cool. But why do we want flow? In order to amplify feedback. So we can tighten these feedback loops, we can make the steering process more continuous. Why do we want to do that? So that we can continually learn and respond to this uncertain environment we live in. Cloud computing. There was a period a number of years ago where Simon Wardley and I briefly fought this losing battle to keep the original term utility computing, because we thought it was really descriptive and meaningful, and the word cloud didn't really mean anything at all. We lost quickly, but the idea of utility computing is that computing resources are things that you can use whenever you need them at whatever level you need them. So if you think of an auto-scaling load balancer, it is detecting a gap or a potential gap between load and capacity, between what you currently expect and what's happening now, and it corrects that gap. And then load starts going down, and it detects another gap, and it corrects that gap as well by lowering your capacity. So it's another cybernetic process. Even user-centered design is fundamentally focused on the idea that we have these bright ideas about what users want and how to give them what they want and the easiest way to help them do things. But the assumption that's built into design is that we're probably wrong. And so we need ways to get feedback, whether it's critique or prototypes or user testing or what have you. Unfortunately, and I'm really angry at Nick, who did the workshop before me, for stealing my unique expression of this, because he said almost exactly the same thing that I'm going to say now. But that's okay. We've developed this metaphor of software as manufacturing, and this idea of linear assembly lines and the industrialization of software, and CI/CD as an assembly line process. And I think part of the problem is exactly what Nick expressed, is that an assembly line is optimized to make the same thing as many times as possible, as efficiently as possible. How do we make 500,000 Honda Accords that all look exactly the same as each other, when what software is about is, well, the first Honda is going to have 3 doors, and the next is going to have 4 doors, and then 5 doors, and front-wheel drive, and then rear-wheel drive, and so on and so forth. So they are fundamentally different problems. But in addition, one is a linear process, and the other is intended to be a circular process. And as a result, we've let some unfortunate terminology leak into the way we talk about things, like a backlog. And yes, we can reorder the backlog, but the fundamental metaphor is that there's this list of things we have to do, and we're going to kind of chew through the backlog one after the other. There are so many problems with the word sprint. I don't even know where to start. But for the sake of this conversation, the implication of a sprint is you start at the starting line and you run really fast in a straight line and then you're done. Release train, right? Trains run on tracks. They don't deviate very well. Even the design thinking principle of the double diamond is you go through this nice kind of cybernetic process of validating your design, but then at some point you're done. There are really interesting conflicts going on these days between the design community and the Agile community. And there's a lot of sort of friction around the idea that, well, we as designers should be able to figure out in advance what users need. And if all you Agile people would get out of our way, we could design better stuff. And I think there's some problems there. And finally, even the term continuous delivery. Continuous delivery is part of what we want, but we've sort of let it become the sum total of what we want. So, if we revisit these practices from a more cybernetic perspective. Why do we have stand-ups? I dread stand-ups where everybody goes around in a circle saying, working on story 1, 2, 3, no blockers. Working on story 4, 5, 6, no blockers. The point of a stand-up is to inspect and adapt. It's an opportunity to say, what do we need to do differently? What's the gap between what we thought we would do yesterday and what we did yesterday, and how do we close that gap? Sprint demos. I had a VP say to me, I was trying to coach him in changing the relationship between development and support, and he said, well, we do sprint demos, we show them what we're going to release before we release it. Well, that's not actually the point of a sprint demo. The point is to give you one last opportunity to say, are we actually about to release the right thing? Right? We built it. Did we get it right? Retros. What went well? What didn't go well? I prefer retros that are a little more structured. Are we actually harnessing change, or is it just driving us? And finally, continuous discovery. And this is the challenge that I put before the design community, which is that particularly in complex systems and environments, solutions create new problems. So the question you want to ask is, what new problems? And this isn't just about design. This is about anything that we do, because we all design stuff. What new problems have our solutions created? So at every level, the approach we want to take is, let's assume that things are not proceeding as we have foreseen, and figure out how and what to do about it. Now, Agile and agility has kind of grown up with somewhat of a process-centric perspective. The writers of the Agile Manifesto didn't spend a lot of time on engineering. They assumed that we know how to write or knew how to write software, we just didn't know how to manage software projects. And to some degree, maybe that was a bad assumption. I think the problem has become more difficult in more contemporary times. But in any case, what we're after and what we're actually starting to do when you look at things like lean UX and MVPs and continuous discovery and so forth, is approach our work as a process of learning and experimentation. But the thing about experiments is you have a hypothesis, and then you have to actually do the experiment. And then you have to understand what were the results of the experiment. And so this is what we call technical agility, which is simply completing that equation. And you could express it very simply by asking the question, and I encourage you all to ask this question of your own organizations. Once you start planning more frequently, weekly instead of yearly, can you deliver value as often as you can plan it? Your 2-week sprint doesn't do any good if it takes 3 weeks to finish a user story, or if you spend the first week of the next sprint fixing bugs from the last one. And again, this is sort of the crabby old man part, which is, this is what I see all too often. These are the kind of bumps and bruises and missing pieces of the puzzle. Is, hey, we have this really mature Scrum process, and we don't really have any control over the size of our user stories. And it's important to say that even though we're trying to be resilient to failure, our goal is not to deliver failure. It's not just how can we push out more work. What we're trying to deliver is value. The goal is to move fast without breaking things as much as possible, and to fix the things that do break quickly. I'm sure you all know, I say this to folks when I give talks outside of Minnesota, that here we have 2 seasons. We have winter and road construction. And you don't want your system to be like road construction season, where you constantly have these signs up that say, this road will be closed from September through November, please go over here instead. So what does technical agility look like? It looks like the ability to do all of the following things. That you can change your code easily and safely, that you can deliver your changes as soon as you make them, that you can rapidly detect and respond to customer impact. And some of this stuff may sound obvious, but for example, if you read the SAFE definition of technical agility, it ends with deployment. That the job of, and they've kind of sucked in team topologies, and they talk about these technically agile, streamlined teams, and this nice long thing, and you design code, and you build it, and you test it, and you deploy it, and then you're done. Well, you're not done. You need to be able to respond to the impact of what you've done. You need to be able to do it without sacrificing security or reliability or scalability or compliance, et cetera, and you need to be able to do it at scale. So there are some principles that we can put into play. The first one is we value flow over quantity. Again, I see quote-unquote mature agile Scrum teams, and maybe they even have nice small user stories, but they still think in terms of, here are all the bugs that we fixed this sprint. Here are all the things that are going into our release. Instead, your key metric, and I actually work with organizations to start by focusing on one metric, and I get in trouble because the DORA folks come along and say, well, you need to do 4 metrics. I like to do 1, which is new value cycle time. How long on average does it take you to deliver one piece of value from end to end? I was strongly influenced by a wonderful article was written a few years ago called The World's Simplest Agile Maturity Metric. And they said, we figured out we only need to measure one thing, which is how often do we deliver new features to production? And if you think about it, if you're responding to an incident, you're not working on a new feature. If you're fixing a bug, you're not working on a new feature. So it forces you to build speed and quality in together and to think end to end. If it takes you a week to test your code and 3 months to deploy your code to production, don't optimize your test time. Optimize your deployment time. So that the model is, if the bus comes along every 10 minutes, you don't need to worry about being stuck waiting for the bus for an hour. So what you're trying to do is optimize the entire process. And this goes back to Gene Kim's first way of DevOps, of how often the bus comes. When we talk about architecting code, we talk about designing for a lot of things: scalability, performance, reliability, security. But part of the implication here is that part of what you need to do as an organization is deliver change. That's part of your business operations. It's part of the value you provide to your customers. So it's part of what you need to architect for. How easy is it to change our code? And this plays out kind of in the whole tech debt conversation. And I'll be honest, I think as engineers, we're terrible at explaining tech debt in terms that make sense to product or to the business. And we fall back into this sort of arcane financial metaphor that only kind of works. But it's actually pretty simple if you look at symptoms of tech debt. Well, this code is so complicated that it takes a week to make a change that should take a day. This code is so fragile and hard to understand that every time we touch it, we break 5 things. In other words, you're increasing your new value cycle time. You are slowing flow, and that is a business problem, right? Product is always like more features faster. It's like, I think a better metaphor is your car. Over time, your car doesn't run as well. It needs an oil change. It needs transmission fluid flush. It needs a valve adjustment. You need to tune up your car so that it can drive as fast as you want to go. Now, while we're changing code, we still need to make sure that our code works. And in order to do that without sacrificing flow, we need to make quality an integral part of the change process. Because guess what? Testing is at the very heart of cybernetics, which is at the heart of all of this stuff that we're trying to do. Right? It's how you identify the gap between actual and expected. I thought this code was going to do this, but it doesn't. And ideally, you want to start all the way at the beginning and define quality together, so that instead of having your POs go off in a corner and type out requirements and user stories as fast as they can, to actually define them together so you can understand from the very beginning, well, what are we trying to accomplish with this code, and how will we know if we're actually accomplishing it? Secondly, tests are software. Continuous integration is a machine. It's software like any other. The only difference is that what it does is it tests other software. And there's a lot of debate and discussion these days about whether developers should write their own tests, whether we should even have dedicated testers, or whether testers should play this kind of nice meta quality architecture role. And from my perspective, it doesn't really matter. That's not actually the interesting question. That depends very much on your organization. The point is that you need to treat writing tests as part of writing code. I've seen teams where the tester and the developer would pair. The developer would write code, the tester would write the test at the same time sitting next to each other. They would run tests together before that code ever got integrated. And you know what? Those two people reported to different vice presidents, and it didn't matter because they worked really well together. Your test code is software. It and the systems under it need to be architected like software. So if it takes you 18 hours to run your test suite, you have a problem. And it's no different from the problem of your code being slow. It's code that's slow. It's code that doesn't scale. And finally, just to throw in one more kind of hopefully but not really obvious one, the point of continuous integration is to find and fix problems as early as possible. So if your builds are failing, you need to fix them. If you're having a debate about whether to fix them or just keep writing code, go back and read the Toyota books and read the theory that delaying fixing defects actually slows you down. It doesn't speed you up. And probably what we should do at C Prime is we should have a class on all of that sort of lean flow theory for product managers and do it in product manager language. This is one of my pet peeves. I see red when I put this slide up. I can't even say what I want to say. Which is that all of your environments should be automated, should be on demand, should be architecturally similar to each other, should use the same automation code. And again, you're sitting there and you're like, yeah, we do Docker, we don't have that problem. I work with organizations that use Docker and they manage their test environments completely manually. And they go through these multi-week processes of requesting IP addresses in order to get a new test environment in order to test their Docker code. And the developers, they don't even use Docker on their laptops. They're like, nah, that's for rookies. We just write code. We're PhDs from Stanford. We don't need Docker. It just gets in our way. And all of that just leads to the dreaded works on my laptop problem, which guess what? Slows you down because you've had a problem go all the way to production and then it comes all the way back instead of fixing it at the left where you need to. One of the things that needs to be shifted left is designing and coding and testing for operability. Again, I see teams where they have this really mature, they do trunk-based development and they have really good test environments and the developers write the tests. And then there's this performance test team that's off in the corner and they're siloed and they're under-resourced and they don't have the right environments and they manage their environments manually, and then they send these reports back to development about the results of the performance tests that the developers may or may not pay attention to. All of this stuff needs to be part and parcel of the daily development process, so that from the very beginning you are thinking about and you are testing, is our code secure? Does our code scale? So on and so forth. And ultimately the reason for that is that when software as service, your customers care about it, which means that your whole organization needs to care about it, which means that it's a product issue, not just an engineering issue, which leads to our next principle of minimizing handoffs. We can talk about lean theory and how handoffs impede flow, but we can also talk about how handoffs slow down feedback. And that when you have product people and development people and ops people talking together as part of the same process at the same time, you get really fast, efficient feedback. As an example, take your designer and your developer, just like the example of the developer and the tester who are pairing. Have your designer and your developer pair, so the designer can look at what the developer implemented from a UI perspective before it gets checked in. And then you get a very fast feedback loop. And as part of enabling that, you want to maximize the visibility of the right things to all of the people, so you have a shared language for understanding what's going on. I worked with a client where we had the bright idea that the POs should go to the ops support meetings. And they did, and they were bored out of their minds. Because the ops people were talking about, well, this server went down, it was because the Linux kernel was the wrong version, and blah, 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 blah. And the POs came to us and said, why are we doing this? And we said, well, we don't really know. And then we got together with them and we showed them some of the Splunk graphs that were on monitors around the building. And we said, you see this line? This means that this morning, the average time it took it to log into your website was 15 seconds. And the POs all went, ooh, that's really bad. And you see this other line? This means that today from 2 until 3 p.m., 15% of your website hits return to 500. And the POs went, ooh, that's really bad. Because the POs understood the impact of the technical information. And then the head of the PO organization that said something, it was one of those moments in my career where I thought, ooh, maybe I've actually provided some value here. She said, maybe we should be the ones reporting on these graphs in the production meetings. I was like, whoa, a PO manager wants to look at and talk about Splunk graphs. That's the Holy Grail. And it's about getting the information in the right language and creating a shared model. Now again, SAFe says technical agility means that when you've deployed code, you're done. Nothing could be further from the truth. If we're talking cybernetics, we're talking a loop. It has to come back upstream. Another pet peeve of mine is the current discourse around SRE. And 9 times out of 10, in the past year, when I look at an SRE job description, it's a good old-fashioned IT ops job description. It's completely siloed. It's doing almost all the same stuff that IT operations did 20 years ago. The only difference is the word automation is in there somewhere. But there's no DevOps, there's no collaboration, none of that. And so, you know, you get to the right side of things and you still have these organizations where an incident comes in and a level 1 support person looks at it and says, oh, I don't know how to fix this. And they put it in a queue and it sits in the queue, and a level 2 person looks at it and says, well, I'm the wrong person, and they put it in another queue, and guess what? You have delay. You have slowed flow and slowed feedback. So an important piece of the puzzle, and there's been really interesting work done with things like swarms, where you basically, the same way that you have cross-functional teams that are delivering code, you have cross-functional multi-level support teams that are responding to problems. Okay, so DevOps comes along and says, you know, we can solve all these problems. We got it, it's under control. Step aside, Sonny. You just have to break down silos between dev and ops. But it turns out that that problem is a little harder than it looks. You know, sort of the core essence of DevOps could be expressed as you build it, you run it. That doesn't work in a vacuum. I worked for a startup a long time ago now, and we did everything. We got colo space, we bought and racked and cabled our servers, we managed the OS and the database and the application, and that was all good, but the reality is that that model doesn't work in anything larger than about a 30-person engineering organization, let alone an enterprise. And the funny thing about DevOps is when you look at it, or at least kind of DevOps 1.0, is it secretly assumed a cloud. It assumed that infrastructure had been turned into this kind of transparent magic thing that application teams could just sort of use, and they didn't have to worry about it. Luckily, the team topologies folks came along and rescued us. And what they did was they sat down and they said, okay, how do you actually make DevOps work in the real world when you have a real-sized organization? And they thought about the problem as maximizing flow, and they thought about the things that get in the way of flow. And one of the things they identified was the idea of cognitive load. That when you have to worry about too many things, it gets in the way of being able to focus on your mission. And those too many things might be things like having to understand the entire Smalltalk image in order to build a very simple MVC app. Or it might be having to worry about all the vagaries of managing your own Jenkins instance at the same time that you're just trying to get code out the door. So they developed a set of patterns that are basically real-world DevOps patterns. And there are really two parts to it. The first part is to create a set of communication structures that maximize flow, the flow of change, which is what we're after. And they call those stream-aligned teams. And in this case, a value stream is basically you design it, you build it, you test it, you run it. It's exactly this cross-functional delivery team that we're talking about. But they added a couple of important pieces underneath it. One is the idea of a platform team that we're all hearing about now. And you may have noticed that, according to the thought leaders, platform engineering has replaced DevOps. Okay, good luck with that. But platform teams are important. The job of a platform team is to provide the scaffolding that reduces the cognitive load with all the stuff you need to do in order to just move stuff towards production with minimal friction and respond to stuff in production with minimal friction. And then the other piece of the puzzle is so-called enabling, or a term I actually like better is technical consulting teams. And their job is to represent things like security and compliance and quality in a way that, rather than siloing them out into gates, actually helps the process of building that expertise and building that capability into the delivery teams. And so when you put these together, it gives you a foundation or a scaffolding to be able to achieve technical agility at scale. But there's still an important missing piece. Imagine your CIO says, you know what? We're going to go cloud native, and I'm going to buy OpenShift and spend $4 million or whatever OpenShift costs. And in the next 2 years, I want the entire organization moved onto OpenShift using cloud native principles and containers and Docker and so on and so forth. And here's X dollars to spin up an OpenShift platform team. And the team dutifully spins up OpenShift and creates a whole farm for it and says, okay, here you go. Everybody come do your OpenShift thing. And the application teams say, you know what? We have no idea how to do cloud native. We've never used Docker. We have all of this legacy code. Doesn't quite work. The missing piece is that too often platform engineering teams and enabling teams bring along with them a legacy approach to IT altogether, which is ticket-driven, it's project-based, it's focused on doing engineering and implementing engineering requirements. And what needs to happen instead is all of these foundational teams need to operate like product organizations, like any other product organization. It's just that their customers are internal application delivery teams. So they need to become proactive, focused on customer value, focused on continuous user-centered learning. And the gauntlet here was really thrown down by the public cloud providers, who are continuously saying, how can we make this easier? How can we move up the stack? How can we provide new capabilities? You know, AWS every year, you know, they have reInvent and they say, here are the 269,000 things that we released in the last 12 months. And they're releasing things and they're betaing things constantly. Their relationship with their customers is proactive, not reactive. And for all of this team topology stuff to work, and for any of it to work at all, really, this is the model we need to move to. And so you see things like POs getting parachuted. The CI/CD team now has a PO. Does that PO actually know how to manage products? Or are they just a tech lead or a program manager who's been repurposed? But hang on, microservices are going to solve all of our problems. One of the insights at the heart of team topologies is our old friend Conway's Law, which simply expressed says that the shape of your organization drives the shape of your software. So if the shape of your organization isn't suited to microservices and you try and build microservices, guess what they're going to lose? The other thing about it is that microservices trade delivery simplicity for operational complexity. And what I counsel people to do is when you start talking about microservices, don't stop, but tread carefully and tread slowly. And learn as you go, because you are going to bump into a lot of walls. However, microservices does point us in a really good direction, because the basic idea behind it is that small things are easier to understand and easier to manage and easy to change, and that's exactly what we are after. And so one of the things that I keep meaning to do, and one of these days I'm going to do it, I'm going to get C Prime to let me do it, is to create a consulting practice that consists of nothing more than going around to every part of an organization and saying the same sentence over and over again, which is make your work smaller. Make your user stories smaller, make your builds smaller, make your tests smaller, make your releases smaller, make your teams smaller. And this doesn't just apply to what you're building, it applies to how you're changing. It's funny because as engineers, what we do for a living is we take big problems and we break them down into small problems, right? We're going to build this application and we need some modules, and those modules need some classes. Those classes need some methods, and those methods need some lines of code. But from a cybernetic perspective, a perspective of trying to navigate our way incrementally towards an uncertain future, we seem to be really bad at it. We seem to want a big bang changes, right? Microservices. We got this monolith, and it's terrible, and it causes problems. So we're going to re-architect it into microservices. And dear CIO or CTO, can we please have $2 million in a year and a half so we can go off and re-architect our systems into microservices? Instead of saying, well, how can we make our monolith a little bit easier to turn into a set of microservices? I worked with a team that their build cycle was 8 days. And the worst part was that if they found a problem on the 7th day, the clock started over, so now it was 15 days. And they said, well, we need continuous delivery. We ought to be able to do a build in 10 minutes. We want to be able to do 10 deploys a day. It's like, okay, slow down. How about instead, we start by going from 8 days to 7 days, and 7 days to 4 days. Or maybe even just figuring out how to not have to start the clock over on day 7. This, to me, is the hardest part of the whole thing. Is, you know, the ThoughtWorks workshop was great, and it put up a lot of really good things, particularly towards the end, about things you want to be doing. There's a lot of them. How are you going to get from here to there? If there's anything that I have succeeded in communicating in this talk, it's you're not going to get there in a big pre-planned recipe kind of way. The thing about technical agility or DevOps, or call it whatever you want, is there's a lot of stuff to it, and almost all of it involves turning the way that we've learned how to do engineering on its head, right? Trunk-based development. I mean, I'm old enough that I actually used ClearCase a little bit. And I've done a lot of work with figuring out how to manage really big, really complicated sets of release branches, right? And then somebody comes along and says, nope, throw all of that away. Just commit to trunk 14 times a day. It's like, holy mackerel. An organization isn't going to wrap its head around that in a single day or in a single step. So a way that we find effective is to take a very effective maturity approach where you start with your outcomes. How effective? If technical agility is the ability to deliver value as often as you can plan it, how effective are we at it? And how effective are we at the various practices that make it up, and which are the best places to get better at next? So maybe we don't do trunk-based development. We don't understand it. Our engineers think it's kind of crazy anyway. But you know what? That's not our biggest problem. Our biggest problem is that our test environments are a disaster. They're all manually managed. They all drift from each other. They're broken half the time. Let's spend some effort fixing that. And one of the objections I get, particularly from overwhelmed operations organizations, is, or even development teams that are being pushed, get more features out the door faster, is this is all great, we don't have time. And so the strategy that I like to use is what I call digging yourself out of the snow, which again works really well here in Minnesota. I really ought to have a picture. I have a great picture of my mailbox this week, which is like just barely peeking up out of the snow. The idea of digging out of the snow is how can we take 2 hours to do some work that will give us 4 hours back? And then how can we take those 4 hours and do some work that will give us 10 hours back? And gradually make things a little bit better every day, which again, just seems to be super hard for engineers to wrap our heads around. So in summary, what technical agility is trying to accomplish is bringing us back to this idea of a complete feedback loop that you can use to steer as continuously and with as much control as possible. And in closing, one of the things it does say on the front page of the Agile Manifesto is we value responding to change. And what we're talking about here is the ability to process signals. Those signals might come from the market, they might come from your customers, they might come from your tests, they might come from your production systems, and being technically agile enough in all of the ways that you need to be able to respond to that change, not just go, oh, there's something we need to do, how do we plan it? So thank you very much.
Yeah, thank you, Jeff. I think we have time for maybe one or two quick questions here. We're running a little bit late, but if anybody has a question here for Jeff, we can probably take one or two. All right, I think everybody's ready for the Bureauspective. So that's coming up next. Thank you, Jeff. That was
Thank
awesome.
you.
I will just take a minute, I promise. I just want to thank a bunch of folks organizing an event like this big work, and without the help of our event coordinators, Jen Nato at U of M and Kyle Anderson, this wouldn't have been possible. So if things are working fine, it's because of their efforts. I want to thank Dave Larrabee, who is kind of our advisor at large. We consult with him to brainstorm and bring topics and speakers. Thanks to our student volunteers, staff volunteers, the staff at McNamara, our wonderful panel of speakers, and finally you. I mean, you come and support us every year. You suggest topics. We take your feedback seriously, so please do fill up those feedbacks that you have been seeing this, in all those QR codes in those talks. I will also post it on the website. So with that, I'll kind of close this event and announce that the bar is open there. It's a cash bar this time. We don't have a sponsor, so the bar would be open, and enjoy the rest of the day and socialize. Thank you.